Hello viewers, I'm Kausalya. Today we are going to solve problems related with RC transients. So here the problem is, in the circuit shown below, the switch S is in position 1 till steady state conditions are reached and then moved to 2. Find the energy dissipated in the two resistors. Show that this is equal to the energy stored in the capacitor before moving the switch. So here the thing is, this is the given circuit diagram, right? Initially, the switch is in position 1. So the switch is in position 1 till the steady state condition is reached. So here what do you mean by steady state? That is, we are having a steady flow of current in the circuit, right? Then the next thing is, here we are having a source voltage of 100 volt, right? So this same 100 voltage is built up by this capacitor across it, right? That condition is known as steady state. That is, the maximum voltage will be found across your capacitor. That is the constraint of a steady state condition. So now, when you solve, you see, during steady state condition, the voltage across the capacitor is 100 volt, right? So it reaches its maximum limit. So when the switch is moved from position 1 to position 2, right? So here, now the voltage across this capacitor is 100 volt, right? So when you write KVL, you see, here when you observe keenly, it is clear, right? These two resistors are connected in series because this is the circuit we are going to consider now. So these two resistors are in series. So 200 plus 300 gives 500. Therefore, 500 into I, right? The respective drop across the resistors are 500 into I plus the voltage across the capacitor is given by 1 by C integral of I into dt. And here the voltage across the capacitor, right? Only because of this voltage across the capacitor, there is a current flow in this circuit. So here the source voltage, we are not considering the source voltage. The voltage across the capacitor is 100 volt here, right? That is voltage rise, and these are all the respective voltage drops. Okay, we are writing this expression based on KVL. So for this type of circuits, what is the expression for I? It is given by E by R into e to the power minus T by RC, right? So here the value of E is 100. What is the value of R? Here we are having two resistors in series. Therefore, the value of R is 500, right? And here we know the value of R and C. So just substitute it. And finally, we are ending up with the expression like this, right? 0.2 into e to the power minus 20t. Next, we are going to calculate the energy dissipated in the resistors. So here energy dissipated is nothing but, okay, it is the power. So here it is given by I square R into dt, right? And here the limits are 0 to infinity. Now just substitute the values here. The value of R is 500 and what is the value of I? It is 0.2 into e to the power minus 20t. So we have to square this term. So 0.2, when you square it becomes 0.2 into 0.2, and whenever you square an exponential term, just you have to multiply this term by 2. So that becomes minus 40t, right? So here once you solve, that is 500 into 0.2 into 0.2 becomes 20, right? Next, when you integrate this part, e to the power minus 40, here we are getting e to the power minus 40 divided by minus 40, right? So the limit is again 0 to infinity. Now you see 20 by minus 40 becomes minus 0.5 and this exponential term remains as such. Now we are going to substitute the limits. So initially you have to substitute the upper limit minus, then you have to substitute the lower limit. So here when you substitute, e to the power infinity becomes 0, minus of e to the power 0 becomes 1, right? So here minus 0.5 into minus 1 gives you 0.5 joules, right? Now we are going to calculate the energy stored in the capacitor. So energy stored in the capacitor is given by the basic formula of CV square. So here in this case the value of C is 100 microfarad and the value of V is 100 volt, right? So just substitute the values and you see finally here again we are getting the same answer as 0.5 joules. So energy dissipated by the resistor is 0.5 joules and here the energy stored in the capacitor is 0.5 joules, right? So this should tally in a circuit because only the voltage across the capacitor acts as a source voltage, right? Therefore, this energy stored in the capacitor will be dissipated by the resistors in that particular circuit, right? So here comes the end of this problem. We will proceed with our next one. The problem is C1 in the figure has an initial charge Q0 equal to 12 into 10 to the power minus 4 coulombs, while C2 has no initial charge. The switch is closed at t equal to 0. Find the current transient and the final voltage of the capacitor C1. So here this is the circuit. The circuit has two capacitors and one resistor. So the initial charge on the capacitor C1 is 12 microfarad, right? Whereas there is no voltage across C2. Then the next thing is the switch is closed at some t equal to 0, right? So we have to find the transient current and the final voltage of the capacitor C1, right? So since this capacitor C1 has an initial charge of 12 into 10 to the power minus 4 coulomb, there will be some initial voltage, right? So first we are going to calculate the voltage across this capacitor C1. So voltage is given by the formula Q0 by C. So Q0 is 12 into 10 to the power minus 4 and the value of the capacitor is 12 microfarad, which is 12 into 10 to the power minus 6. So once you solve, the initial voltage is 100 volt, right? The next we are going to apply KVL for this circuit. So when you write KVL, again you see 1 by C1 integral of I into dt plus voltage across the resistor is given by I into R. So let I is the current that flows through the circuit, right? Therefore 50 into I, and here again 1 by C2 integral of I into dt, right? So these are all the voltage drops across the respective elements, so which will be equal to your source voltage. Here you see there is no source voltage, therefore the voltage across the capacitor is taken as the voltage here. So here it is 100 volt, just now we have calculated, right? So just write down the expression, so which is equal to 100, right? Name it as equation number 1. Can you get? These are all the sum of voltage drops and this is your voltage rise. That's it. Now you see here we are having two capacitors and the two capacitors are connected in series. So now I am going to find the total capacitance of the circuit. So total capacitance of the circuit is, you see, this is the expression. So 1 by C is given by 1 by C1 plus 1 by C2. So just substitute the values here and finally the value of capacitance is 4 microfarad, right? So instead of writing these two expressions, we can replace it with a single capacitance because they both have the same current flowing through them, right? So this equation gets modified as, you see, 50I, okay? This 50I we are writing as such. Then these two expressions are combined as a single one, which is 1 by C integral of I into dt, which is equal to 100, right? Next we are writing an expression for current. So expression for current is given by, for an RC circuit, the basic expression is E by R into e to the power minus T by RC. So here we know the value of E is 100, R is 50 and R and C just substitute the values. So again when you solve, the expression for current is 2 into e to the power minus 5000 T, right? So this is the current that flows through the circuit. So in this question, so the first part is over, right? We have calculated the transient current and the next thing is we have to calculate the final voltage of the capacitor C1, right? So the initial voltage across the capacitor C1 is calculated as 100 volt, right? Now we have to calculate the final voltage. So So look at this expression carefully. You see the initial voltage across the capacitor C1 is 100, right? So we have to calculate the final voltage. So how to calculate the final voltage? We have to subtract initial volt, that is we have to subtract the respective drop across the capacitor, right, from the initial voltage. So here the initial voltage is 100 and the respective drop across the capacitor C1 is given by 1 by C1 integral of I into dt, right? Can you get? This is your initial voltage, right, and this is your respective drop created by the capacitor. So once you subtract this drop from the initial voltage, then we can get the final voltage. So just substitute the values. We know the value of C1, we know the expression for I of t, so just substitute it over here. So here in this case, you see 2 is a constant, so we are taking it outside, and when you integrate this exponential term, it is e to the power minus 5000t divided by, here comes minus 5000, right? And now again I am taking this 5000 outside. So after taking this, I am substituting the limits, right? So minimum is 0 and the maximum limit is t here. So when you substitute it, you see e to the power minus 5000t minus of e to the power 0, right? So again, when you solve this expression, we are getting the value as 100 by 3, or you can directly write 33.33, right? So here we are having, again you see, minus into minus becomes plus, okay? So here it becomes plus here, and we are having the expression. And now I am rearranging this equation. So when I rearrange it here, this minus E naught gives the value as 1, right? So I am rewriting this. So e to the power 0 comes first and then this one. So I am taking minus outside. So when I take minus outside, that becomes 100 minus 100 by 3 of 1 minus e to the power minus 5000t. Right. So here you may have a question, what is the need? Why we have to take this minus outside? So when you keenly observe, you see, the initial voltage across this capacitor is 100 volt. Right. So once this switch is closed, automatically this acts as a source of voltage, and because of this 100 volt, there is a current that flows through this circuit. Right. So the final voltage should be either less than this 100 volt or greater than this 100 volt. You just make a guess. The total source voltage by itself is 100 volt. So what about the final voltage? It should be less than this 100 volt. Okay, it should never be greater than this 100. Therefore, here we are taking this minus outside. Right. So when you add, it becomes greater than 100, which is absolutely wrong. Therefore, here when you take this minus outside, again this forms the basic expression format, right? So 100 minus 100 by 3, that gives the answer as 66.7 volt. So this is the final voltage across the capacitor, okay? You just write final voltage so that you won't get confused. Right, the initial voltage is 100, and after some dissipation, after giving the circuit a flow of current, its value gets reduced to 66.7 volts, right? So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.